Hello friends, today I am going to discuss with the topic of derivative of parametric function. Before this, what is meaning of parametric function? We already learned this in 11th standard as a type of function. So parametric functions are the function in which the Cartesian coordinates x and y can be expressed in third variable. Suppose we take that function x is equal to f of theta, y is equal to g of theta, where theta is the parameter. Instead of theta, you take another parameter also. Suppose you can take x is equal to f of t and y is equal to g of t. Then there is parameter as t. So by using this parameter, we have to find its differentiation. So for differentiation, as x is a function of given parameter, y is a function of given parameter, then we take differentiation of y with respect to x or sometimes differentiation of x with respect to y by defining their differentiation with respect to their parameters. So for this case, we will take derivative of x with respect to y by using result as dx by d theta divided by dy by d theta. And second, dy by dx means derivative of y with respect to x can be defined as dy by d theta divided by dx by d theta. That depends on the condition given to you. Now for this parametric equation we take example as x is equal to 80 square, y is equal to twice 80. These are the parametric equation of parabola. Again, we have seen this in 11th standard as the parametric equation of parabola. For circle, parametric equation a cos theta, x is equal to a cos theta, y is equal to a sin theta. Again, for ellipse, we take that parametric equation x is equal to a cos theta, y is equal to b sin theta. And again, for hyperbola, we take that parametric equations as x is equal to a sec theta, y is equal to b tan theta. Again, we may use another equations, but for this we take here, as these are the parametric equation of parabola, we take t is the parameter. And remaining three equations for the conics, circle, ellipse and hyperbola. So for this we take parameters are theta because that is in the form of angle. So we use theta, and here for parabola t is any constant. Now for this we take the derivative of parametric function as a theorem statement as if x is a function of t and y is a function of t, both are differentiable function of t. Again, one more condition, so that y is differentiable function of x. Then, to show that dy by dx is equal to dy by dt upon dx by dt, where denominator dx by dt is not equal to 0. This result is very easy to prove because as we take the parameter Rt and both x and y are differentiable with respect to x. Therefore, we can find their derivative easily. For this we take by taking incrementary ratios as delta y delta x. So we take here delta y delta x with the increments in y and x corresponding to the increment delta t in t, where t is the parameter. Delta y, delta x are small increment in y and x corresponding to the increment delta t in variable t or parameter t. Now we consider delta y by delta x. This is the incrementary ratio that can be adjusted as product of, or you may take that can be adjusted as division of delta y by delta t upon delta x by delta t, assuming that the denominator never 0, means delta x by delta t is not equal to 0. Delta y by delta x, that ratio can be adjusted by taking again division of this. Now as we have to given that x and y are functions of t, so we take as delta x tends to 0, that must imply delta t tends to 0 because x is a function of t, x itself with its increment approaches to 0, then delta t also approaches to 0. Now we consider this is suppose equation 1. For the equation 1, we can take limit on both sides as delta x tends to 0. Now for this equation, we take limit delta x tends to 0, that becomes delta y by delta x is equal to limit delta x tends to 0, delta y by delta t whole divided by delta x by delta t. Now by using algebra for limit of division of two function or ratios is nothing but division of their limits. So we separate out this limit delta y by delta t as delta x tends to 0. Again for denominator, limit delta x tends to 0, delta x by delta t. As we have to given that, so that y is differentiable function of x. So see here for this equation, after taking limit, left side of this equation means limit delta x tends to 0, delta y by delta x. That limit exists and finite. So we can take its value. Its value is equal to dy by dx. So LHS of this equation is equal to dy by dx. For this equation, we take LHS is equal to dy by dx because y is a differentiable function of s. Now question about its right side. For right side again, first statement is given as x and y are differentiable function of t, and again x is a function of t. So for this right side, this limit can be considered as, instead of delta x tends to 0, we write this as delta t tends to 0 because x is a function of t, and using this condition, so for right side, for RHS of second equation, take down limit as delta t tends to 0, delta y by delta t upon delta x by delta t. Again by using algebra of limit of division of two function is nothing but division of their limit. So that right side of the equation 2 becomes dy by dt upon dx by dt. Dy by dt upon dx by dt means ratio of incrementary function as the denominator approaches to 0, and by using Leibniz rule that limit exists and finite with its values as derivative of y with respect to t divided by derivative of x with respect to t. So as LHS is divided by dx, RHS is divided by dt upon dx by dt. So combine. Therefore LHS equal to dy by dx and which is equal to RHS, that is dy by dt upon dx by dt, where dx by dt always non-zero. This is the derivative of that function y with respect to x, where y and x are again the functions of third variable, that is parameter t, and therefore that can be expressed as the division of their derivatives with respect to that parameter. This is very important result as the derivative of parametric function. Many times that question is asked in board exam for 3 marks, or if suppose example is asked on this theorem, then that carries 4 marks. Now we see some examples on this theorem as the derivative of parametric function. Again examples are very easy. Again there is one more condition. If x and y are given again a new third variable and you have to find their derivative, so we use the concept of differentiation of that function with the corresponding operator. Now from the exercise 1.4, we saw some examples on it. From exercise 1.4, there are 2 questions are given on this topic. Exercise 1.4, first question. Find divide by dx. D. So take here one or two questions on this question. X is equal to 80 square and y is equal to twice it. X is equal to 80 square, y is equal to twice it. And second question. X is equal to a into 1 minus cos theta. X is equal to a into 1 minus cos theta and y is equal to a into b into theta minus sin theta. B into theta minus sin theta. Now for the first function, x and y can be expressed in third variable, that is t. So we take here t is the parameter. So for this we take differentiation of x and y with respect to t. And for second question we take here theta is the parameter because x and y both are expressed in terms of theta. Again a and b are some constant. So in order to find divide by dx, so we take here first question. Given x is equal to 80 square and y is equal to twice 80. T is the parameter, so we take differentiation with respect to x for both functions. Here parameter is t, so we take differentiation with respect to t for x and y. So for first we take derivative of x with respect to t, dx by dt. A is constant and derivative of t square is 2t. Now here y is differentiated again with respect to t. So we take divide by dt is equal to a is a constant number and derivative of t with respect to t, that is dt by dt, its value becomes 1. So by using definition of derivative of parametric function, divide by dx is equal to divide by dt upon dx by dt. Now value of divide by dt from our two equations, that is divide by dt is equal to twice a and dx by dt is equal to twice a t. So after simplification we get that value. To cancel a cancel 1 upon t. So derivative of y with respect to x always as a function of t is in the terms of function of given parameter. Now for second question, given that x is equal to a into 1 minus cos theta and y is equal to b into theta minus sin theta. So again we take theta as the parameter. So differentiate x and y with respect to theta. Differentiate x and y with respect to theta. Now we find derivative of x with respect to theta here, dx by d theta. Dx by d theta. Now here product of two functions, so we take a is the constant, derivative of 1 is 0, minus sign as it is, derivative of cos theta is minus sin theta, that minus and this minus becomes plus. So we can take here that derivative is a times sin theta. Now for y, derivative of y with respect to theta, divide by d theta. So divide by d theta, again here take b is constant, derivative of this theta with respect to theta means d theta by d theta, that becomes 1. Next minus, again find derivative of sin theta. Derivative of sin theta with respect to theta is cos theta. So we take that is b into 1 minus cos theta to find divide by dx. So divide by dx is equal to, by definition of derivative of parametric function, as the parameter is theta, so is equal to divide by d theta upon dx by d theta. Now we take value of divide by d theta, b into 1 minus cos theta and here a into sin theta. But many times that question is given with the CT options as answering half angle result. So we may write this as B into, 1 minus cos theta is equal to 2 times sin square theta by 2. And that term, half angle, double angle formula for sin theta, 2 times sin theta by 2 into cos theta by 2. 1 minus cos theta, 2 sin square theta by 2, and a sin theta, a is constant, sin theta is 2 sin theta by 2 into cos theta by 2. 2 here cancel, one of the sin ratio cancel, then we get that value becomes b upon a. Sin theta by 2 upon cos theta by 2 means tan theta by 2. Sin p upon a into tan theta by 2. Suppose you have to find this value and theta is, some number is given. Suppose theta is pi by 2. So again we take pi by 2 means 90. Again its is 45. So that value becomes only b upon a. So the second question of this exercise is of this type, as to find the value of dy by dx at given values of the parameters. These values of the parameters are provided to you. Now we solve the question on finding the value of dy by dx at values of parameter. So for second question, we take find dy by dx if. So here we take separate questions. Very easy topic, only simple questions are asked to you for point of view of examination. Now here we take one of the example as if x is equal to a cos cube theta, x is equal to a cos cube theta, and y is equal to a sin cube theta, a sin cube theta. So find dy by dx if this x and y are given to you, also theta is given, that is 5 by 6. Theta is given 5 by 6. 5 by 6 means 30 degree. Now, so what is given? X is equal to a cos cube theta, y is equal to a sin cube theta. Now here parameter is theta, so we take differentiation of x, y with respect to theta. The theta with the given parameter. So we get here dx by d theta, a is constant, by composite function derivative of cos cube theta. Use here result of x raised to x. What is the derivative of cos cube theta? So that becomes 3 cos square theta. After finding derivative of cubic function, we find derivative of its proper function, that is base cos theta is minus sin theta. So can take that sign is here. Derivative of a cos cube theta is minus 3a cos square theta into sin theta, and that of derivative of y with respect to theta divided by d theta. Again a is constant. Find in similar manner derivative of sin cube theta, that becomes 3 sin square theta, and up to this we find derivative of sin theta is cos theta. Now to find value of dy by dx at the given parameter, theta is equal to 5 by 6. Now by using definition of parametric function, dy by dx is equal to dy by d theta upon dx by d theta. Every time you can write definition dy by dx, because we first find derivative of x here, and when we apply the result, we write numerator as derivative of y with respect to theta. So you can write this formula and take proper values of this. Dy by d theta is equal to a 3 sin square theta into cos theta. Or we may write 3a sin square theta into cos theta. Divide by minus a into 3 into cos square theta into sin theta. Now simplify this. A cancel, 3 cancel, one of the sin ratio cancel, one of the cos ratio cancel. You get that value of dy by dx is equal to minus sin theta upon cos theta, that is tan theta. This is the value of dy by dx. But value, to find this value, to find dy by dx and theta is equal to 5 by 6. So we take here value of dy by dx and theta is equal to 5 by 6. Means in the ratio of tangent we take value of theta. That value is 5 by 6. So this tan 5 by 6. 5 by 6 means we take that value is 30 and tan 30 is 1 by root 3. As you have to given 5 by 6, so we take tan 30. If you have to given 5 by 4, you get that value is 1. If you have to given 5 by 2, then you get infinity. So depending on the value of that, so you can take that value. Tan 5 by 6 is 1 by root 3. Sin theta upon cos theta, that ratio gives value of the dy by dx at the variable theta, which is equal to 5 by 6. Again that question, suppose the value is given and theta is equal to 5 by 3. So we can take that value dy by dx and theta is equal to 5 by 3. Again this minus tan 5 by 3. What is tan 5 by 3? So that value is 60 and tan 60 is root 3. Again, suppose you only given theta is equal to 5 by 4. Again, same value we take that value is equal to minus 1. This is parametric change. Then you get the different value of the given derivative of the parametric function. So we take smaller value, after this we take bigger value, that is 5 by 3 and then 5 by 4. So at given angle you can find value of the derivative of the function with respect to x. Now we see examples on next topic for which we take the differentiation of first function with respect to differentiation of second function. There is no time given as to find dy by dx. Now to take differentiation of first function with respect to second. Many times question is asked on this topic. So this is the third topic. And sometimes that example can be solved by using substitution method. So you can write here that as if x is equal to e raised to sin 3t and y is equal to e raised to cos 3t, then show that dy by dx is equal to minus of y into log x upon x into log y. Very easy question. You have to given x and y in the forms of exponential function and parameter is t. So to find the derivatives with respect to t, before this, to show in this type, here answer is in the form of log. So we first use logarithmic differentiation, and for this we take x is equal to 3 sin t, x is equal to e raised to sin of 3t, y is equal to e raised to cos of 3t. For this we take log on both sides. So taking log on both sides of x and y. For both function we take. Before this you may find your answer in terms of direct by differentiation of exponential function. So we get here log x is equal to, so we can take log e raised to sin 3t after simplification as this is natural log. So we take sin 3t is the coefficient and value of log is 1. So we take here that value becomes sin 3t. In similar manner we get here log y is equal to cos 3t. Log x equal to sin 3t and y is equal to cos 3t. So differentiation is, as the parameter is differentiate with respect to this parameter t. So derivative of log x with respect to derivative of this log x with respect to t. So for left side we take derivative of log 1 upon x and derivative of x with respect to t, that is dx by dt, and derivative of sin t is equal to cos, but angle is instead of t we take there is 3t, so multiply by 3, cos 3t multiplied by 3. In similar manner differentiation of this log y, differentiation of this with respect to t, derivative of this log y 1 upon y dy by dt. Now derivative of cos 3t, because we find derivative of cos, that is minus sin 3t, and again find derivative of 3t as 3. Now to find or to show, so as dy by dx by derivative of parametric function by using the parameter t, dy by dx is equal to dy by dt upon dx by dt. Now we take their values. Dy by dt is equal to, now this one from this equation we take dy by dt, by shifting y to the right side we get minus 3 into 1 into sin 3t, and here 3 into x into cos 3t. As we shift this x to the right side, so 3x and cos 3t. Now see here 3 is cancelled. To show answer is minus y times log x upon x times log y. Now using this equation 1 and 2, means by taking their log, we get here value of sin 3t is log x and value of cos 3t is log y. So replace minus 1 sin 3t with log x and here x cos 3t with log y from 1 and 2 by taking their logs, and that is the result for dy by dx, which is proving here minus y log x upon x log y. Now suppose if that question is not in the form as show that only you have to find dy by dx, so we may stop our answer here to find derivative of exponential function. As it is, find derivative of sine, again find derivative of 3t by taking some simplification. But to show that, and that expression contains log, and for this we use a logarithmic differentiation. Without taking log, you can also solve this, but in answer, log term is given, and for this case, we take the log for such a question. Now again one more question on this topic. This question is asked in CP question paper also. Given that x is equal to log of 1 plus t square and y is equal to t minus tan inverse t minus tan inverse t, and you have to show that dy by dx is equal to under root of e raised to x minus 1 under root of e raised to x minus 1 upon 2. Again, this is very easy question. as we take x is equal to log of 1 plus t square and y is equal to t minus tan inverse t. Up to from this chapter, up to derivative of parametric function, we take derivative of composite function, derivative of inverse trigonometric function. Only we can use that result to find derivative of x and y with respect to t. So, as the parameter is given t, we can take differentiation of x and y with respect to t. X is equal to log of 1 plus t square and y is equal to t minus tan inverse t. Now, differentiation with respect to t for both x and y. We take common instruction from this dx by dt. Find it of this log 1 upon 1 plus t square. After differentiation of log, we find derivative of 1 plus t square. That is, derivative of 1 is again 0, 0 plus derivative of t square with respect to t. That is 2t. Now, for y, dy by dt, derivative of t with respect to t, just like derivative of x with respect to x. So, here we take that is 1 and derivative of tan inverse t, that is 1 upon 1 plus t square. Derivative of tan inverse t, 1 upon 1 plus t square. Now we take here simplification for this. Cross multiplication of this 1 into 1 plus t square and this remains minus 1 whole divided by 1 plus t square. So value of this t square upon 1 plus t square. Now here value of dx by dt 2t upon 1 plus t square. Now using definition of derivative of parametric function, we can take dy by dx is equal to dy by dt upon dx by dt. So what is the value of dy by dt? From this we take that value t square upon 1 plus t square whole divided by 2t upon 1 plus t square. Now here both terms have same denominator, so we can take cancellation of this. Again from t square upon 2t, we take one of cancellation of t. So answer becomes t by 2. Here value of t is not given to you, so you write that as it is, but our question is on the topic that you show that. And to show that answer in the form of exponential function, so take value of t from equation 1. So we take from equation 1, that is value of x. What is value of 1 plus t square? From equation 1 we take that value 1 plus t square is equal to e raised to x by conversion of logarithmic to exponential form as base is e. So we can take e raised to x is equal to 1 plus t square. Now make this t as free from this 1 and after this square. So we take t square is equal to e raised to x minus 1. So t is equal to under root of e raised to x minus 1. And therefore value of dy by dx. So value of dy by dx we call it as third equation, and therefore from 3 dy by dx is equal to, what is the value of t? Under root of e raised to x minus 1 and divided by 2. So that result is proved here as dy by dx is under root e raised to x minus 1 upon 2. Here only you have to adjust the question according to given instruction, and therefore we get and by using this we get the answer of this. Understand this result? Very easy question, but such a type of questions are asked in question paper for 3 or 4 marks. Very easy, only use some proper substitution or conversion of log to exponential or sometimes inverse to circular function. Now again we take example on next topic, that is differentiation of one variable to another. So for this we take example. Fourth example, differentiate sine inverse of 2x upon 1 plus x square with respect to cos inverse of 1 minus x square upon 1 plus x square. Differentiate sine inverse 2x upon 1 plus x square with respect to cos inverse 1 minus x square upon 1 plus x square. This is again very easy or important question. Only you can understand or remember the formulas we learned already in 11th standard. That is trigonometric ratios sine and cos in terms of tan. So for the double angle we use sine 2 theta is 2t upon 1 plus t square, and for the same t means value of t equal to tan theta, we take cos 2 theta is equal to 1 minus tan square theta upon 1 plus tan square theta. So when you write that question, so you remember that are nothing but the formulas of double angle of sine and cosine. So we take here proper substitution of variable x. So x is nothing but tangent ratio. Sometimes both function have same substitution, or sometimes that function have different substitution. When substitution is in same variable, so we can take differentiation with the third variable. But if substitution is different, then we cannot use the third variable. We take its proper variable in the given question. So for this case here, we take let u is equal to sine inverse 2x upon 1 plus x square and v is equal to cos inverse 1 minus x square upon 1 plus x square. Now using x is equal to tan theta, or we take substitution, put x is equal to tan theta. As in both cases we take x is equal to tan theta, so we never replace that theta as tan inverse x. We may direct take differentiation of both u and v with respect to theta. So by using this we get u is equal to sine inverse 2 tan theta upon 1 plus tan square theta, but that result is the result of sine 2 theta. So your answer is written here only 2 theta. So again same case, v is equal to cos inverse 1 minus tan square theta upon 1 plus tan square theta, that gives the result of cos 2 theta. Again by using inverse trigonometric ratios property we get that value is theta. So u equal to 2 theta, v is equal to 2 theta. Our question to find differentiation of sine inverse of the given number with the cos inverse means to find du by d. We have to find here du by d. Differentiation of this with respect to this. Du by dv, but by definition of parametric function we can take as u and v are functions of x, so we may write this is du by dx, dv by dx. But again that replacement of variable x in the third function, that is theta, so we may take direct which is similar to that of du by d theta, dv by d theta. So d by d theta of 2 theta, and again here d by d theta of 2 theta, because same substitution and same parameter, and therefore our answer becomes here derivative of u with respect to v. Derivative of 2 theta with respect to theta is 2. Again same case here 2, and that value is equal to 1. But instead of this, suppose you can take that value in terms of x. So we get here d by dx of 2 times tan inverse x whole divided by d by dx of 2 times tan inverse x. Because theta is equal to tan inverse x, we can take here a replacement of x by replacement of theta by tan inverse x. 2 is constant, again both have same derivative, so that can be cancelled out and you get answer is 1. But this can be used when both in u and v we can take different substitution, and that can be take in terms of x. By using proper substitution we find derivative of function with respect to second function. So here u and v or x and y are not given to you. You have to given that differentiation of the function with respect to given function. Again we take one of the example from this differentiation of differentiation of 3 raised to x with respect to log of x to the base 3. Sorry, log of 3 to the base x. Log of 3 to the base x. Now in this case, again we take u is the exponential function and v is the logarithmic function. Differentiate 3 raised to x with respect to log of 3 to the base x. So let u is equal to 3 raised to x and v is equal to log of 3 to the base x. And can take here simplification, log 3 upon log x. So both u and v are functions of x. So we can take their differentiation with respect to x. Find du by dx. Very easy question because we take this derivative already in 11th standard. Derivative of exponential function, that is 3 raised to x. Here 3 raised to x into log 3. Now here derivative of v with respect to x, as log 3 is constant, and derivative of 1 upon log x. By using here change of base property, as we have given function is log 3 to the base x, the change of base property log 3 upon log x, but log 3 is constant, term is d by dx of 1 upon log x, means we can write log x raised to minus 1. 1 upon log x, we can write d by dx of log x raised to minus 1. So log 3 is constant. Root of log x raised to minus 1 is minus 1 log x raised to n x raised to n minus 1. Minus 1, that is minus 2. And find again multiplication of derivative of this log x, that is 1 upon x. So simplification of this minus log 3 upon x into log x bracket square. This minus sign comes out, minus of log 3. This log x raised to minus 2 becomes positive and denominator, and this x as it is. Now to find value of derivative of 3 raised to x with respect to log 3 to the base x, means du by dv. So by using rule of derivative of parametric function, here parameter is x, so we take that value du by dx by dv by dx. So du by dx is here 3 raised to x into log 3. And for the second, dv by dx is minus log 3 upon x into log x bracket square. 3 raised to x into log 3 whole divided by minus log 3 upon x into this. So you simplify this. This log 3 is cancelled and the denominator of the function is this and its denominator is the x log x bracket square, which can be reverse multiplied. So we get minus 3 raised to x. This is cancelled out and this can be multiplied, minus 3 raised to x into x log x bracket square. Remember this, how you simplify these. For the first numerator, denominator is 1 and this rational function can be multiplied by reciprocal of it. So this term becomes at numerator, this is for denominator, that can be cancelled out with this log 3. So you can take easy cancellation of this and this can be multiplied to this. So minus 3 raised to x into log x bracket square is the derivative of given function u with respect to x. With respect to second function, that is v. Derivative of 3 raised to x with respect to derivative of log of 3 to the base x. Now up to this we find here derivative of the parametric function or the given variable derivative can be found out by using the result of values of dy by dx. So in some example there is substitution is given and we find the substitution by using standard result of trigonometry, just like cos 2 theta, tan 2 theta, and with the help of this we find the derivative. Now here the topic is over for derivative of parametric function. Tomorrow we see next topic, that is the last topic of the chapter, higher order derivative, and here the topic for parametric function is over. Thanks to all.